Drizzle. So, anyone heard of Drizzle before? Most of you? Some of you? Probably less on Gearman. It's sort of a newer side project we've been working on. So this is Patrick. He's working at Lycos, and you can probably introduce yourself better.
I work at Lycos currently for another 2 weeks. I'm beginning at Northscale. Northscale is a company that's a new startup in the Valley that's going to do things with things like Gearman and Memcached and Drizzle, many other things, cloud computing. I just finished writing a book on developing web applications using Memcached, Perl, and Apache, and Gearman, and Sphinx. Anything else that's kind of new and exciting. And I know Eric for the last year or so.
Yep. Yeah, I work at Sun on the Drizzle development team, but most of my time has actually been working on Gearman so far. But I've been working on the protocol side of Drizzle. Get into that a little bit more. So first, we're going to talk about Drizzle, Gearman, and then an application that Patrick and I, well, Patrick originally started, and then I helped work on later on that tie the two together.
You inspired me, though.
Okay.
Let's get that clear.
Okay. Yeah, an application that ties the two together to see how you can actually start using something like Gearman with a database like Drizzle. And you could actually use it with MySQL as well, but we're going to show off more of Drizzle. So the Drizzle part of the talk is going to roughly follow this overview, just talking about why it was started, you know, some of the community aspects, how they're different from MySQL, and then get into the details of what have we actually changed in the server compared to MySQL, like some architectural approaches that we're taking, and pretty much where we're going with the project. It was started by Brian Aker, who is the director of engineering at MySQL. He was sort of fed up with some of the development model of how MySQL was going. They were sort of going more towards the enterprise market than they were the web market. And you can see that with releases like 5.0 and 5.1, where they got really big with web businesses, and then they started switching, adding things like stored procedures and triggers, and trying to be more a niche player in the enterprise market, which they got popular off of web apps, and he sort of liked that idea and wanted to get back to those basics.
So how do you separate between web market and enterprise market?
So web market is sort of anyone who's coming along with a new website idea, and all they need is a pretty simple database that's really fast, versus a really feature-rich database, but isn't quite as performant as, say, like MySQL has always been known for being really fast for certain types of web queries.
So it's essentially MySQL versus InnoDB?
Well, actually, we'll get into it. InnoDB is our default storage engine now, because transactional is still really safe, and in some terms, InnoDB can be faster than MySQL, but it's more, don't add more code bloat for features that people don't really want. And that's one of the reasons why I have the slide here is that the customer advisory board, so MySQL every year they have some of their core customers come together and say, what do you like, what don't you like, what do you want to see in the future? And no one ever really wanted things like stored procedures and triggers and some of these other features that have been added in 5.0 and 5.1. And these are some of the core customers. They just want really fast, optimized database queries, really simple stuff, your simple select statements and, a few simple joins. Yeah?
Well, that somewhat surprises me because to me, when I'm looking for speed and stuff like this, if I had a proper storage procedure, things are really precompiled in the storage procedure,
yep, that
could be used in certain instances to get significant performance improvements. Mm-hmm. And you're saying that the clientele doesn't.
Yeah.
Does not see that as something that they would like.
They weren't really using them. They weren't demanding them. It was more, there were a few clients that did want them, and that's why they were added. But for the most part, they were looking for the core clients of MySQL were not looking for those features. They just wanted really fast.
But given the way the storage procedures were done, they were not done with a view toward improving lookup performance.
Yeah.
And they don't, because they don't.
No, there is some overhead with storage procedures.
But
yeah,
they're also they're not precompiled in MySQL.
No, they're not.
No.
So that so that you lose those advantages, those types of advantages.
Right. Even prepared statements aren't as optimized as they could be. So in a prepared statement, most
The way they
Most
implement it
clients-
for
most database systems with a prepared statement, it gets compiled once in the server and gets put in the shared memory in the server, and is used over and over and over. In MySQL, it's compiled once per connection or per thread. I forget which.
I think so, yeah.
It's one of the two, but most people are just kind of using like a non-persistent connections
Yeah.
with MySQL because that's what it's really
Yeah.
good for.
or connection pools where you don't know which connection you're going to have, and you may not have that
Right.
prepared statement. But even the features, the way that they added them, like stored procedures, could have been in a much more modular fashion and could have been more useful. Instead of using some one-off syntax, you could have done what like Postgres does and implement real languages that people use rather than the stored procedure language.
Right, and the things people are asking for aren't getting in there. For example, someone just today asked me, "Hey, does MySQL work with LDAP authentication?" And that's something that people have been like demanding forever,
Yeah.
and has never got in there. So anyway,
Yeah. So Brian was seeing a lot of there wasn't a lot of demand for these features, and the features that they added, they were sort of done in not the most modular or really the most efficient way that could have been done, and it actually was adding some overhead in cases where it shouldn't have. Like authentication does add overhead even if you disable authentication in your server, like disabling your grant tables. There's still overhead in those connections. So he started sort of going back to the drawing board, and over the next couple of years he started jotting things down on on notepads and thinking like, if you were starting from scratch, what would you actually do here? What would you rip out? What would you re-implement? And he just took the idea of rethinking everything within the server, but make sure you keep the stuff that was done well. And another big thing that struck him is with some of the performance characteristics of MySQL, it's not really scaling that well. You're seeing people like Percona starting to implement patches on top of NODB to make it scale to 8 cores. And we're already looking at 16 and 32 core processors for Intel, and much larger, obviously, for Spark-based processors. So you want to take the approach of take the code that you're writing and think, where is the database market going to be 2 or 3 years from now, or maybe even 5 years from now? Like, how are we going to scale at 128 cores or 256? Don't be fighting, 16 core Intel chips just came out. Let's catch up to that. Benchmark. And the same with RAM. Like RAM is getting really cheap and really large these days. Don't worry if you only have 8 gigs in your server. It's going to be okay to be able to run this on 32 or 64 gig machines. So you start looking at your database constraints a little differently in your development environment. Like, what can you actually start doing that wasn't an option before? Because there was a lot of code in MySQL that was there for legacy purposes to run on old Unireg machines and in VMS. Like, that's not really a factor anymore. We don't need this code hindering performance. So he announced it last year at OSCON, and this is when the team at Sun really got started in July. And some of the core visions is to make a microkernel architecture, and we'll get into that a little bit more later, but that is, rather than having this big monolithic kernel where you're just adding new features onto this big code base, start ripping it apart and making plugin interfaces. Like storage engines and user-defined functions are the only real interfaces you have into extending the MySQL server at this point. Let's push that to new limits, and you'll see an image later on that shows where we're taking that idea. And with that plugin infrastructure, you start making it more aware of your environment. Like, you can integrate into like an LDAP server, like Sherry was talking about. You don't have to write a script that dumps your LDAP server and imports into your grant tables and flushes that every half hour. You can start integrating directly into the server code so you can auth against that server. One of the big things is, like I mentioned before, focusing on web apps rather than the enterprise market. That's one of the original goals of the project.
So multiple storage engines are not an option, right?
Nope,
No,
we
they
still
are
have that.
very much so.
Yeah,
Very
we
much.
still have that. Yeah, I'll talk about the storage engine interface a little bit more later. So the code base, is in MySQL is usually referred to as C+. It's somewhere between C and C++. And it leads to really bug-prone code. Like, you end up having, a C struct being allocated memory, and then you have a C++ class trying to destruct it later on, and you're just going to end up, losing memory or blowing things up in the server. Like some of the stuff we've been digging through lately is switching everything from mallocs to news in the code, and if you allocate a C++ class and then try to clear all the memory in it, you could be wiping out the virtual memory table, and who knows what that's going to do on some implementations. Yeah.
If you were starting to code from scratch, and you asked the question, should you do it all in C or all in C++? What would your decision be?
I'm biased, and I would say C. But we took MySQL 6 and forked it from there, and having everything in half C and half C++.
No, I understand that. You got to pick one or the other. I'm just curious as what your.
Personally, I would probably pick C because that's what I've been doing for the past 10 years. We have different views on that, like within the Drizzle team. I don't know, what would you?
It is difficult to have 100,000 lines in C.
As opposed to C++.
Right.
It's going to be difficult.
There are arguments for both. I mean, for C, you'd get the speed and it'd be fast. For C++, though, you have nice, have inheritance, things like inheritance, where you have a table object or a field object, and you can subclass those into ints and varchars and so.
Just be curious to me how useful that would be.
Well, you could do something like that in C, probably.
Yeah.
But
I don't even know that it's that useful. I'm curious, as you look at it, ultimately, what you really want is some language that doesn't exist, which would be clean.
Or you can do objective stuff.
I was gonna say, isn't that Lisp? But the thing is that if you have developers who are comfortable developing in a certain manner, like if they're comfortable with the object-oriented model, you're going to get better code out of them if they're using C++ than if they're using C. You know what I mean? So you'll get, and you do get purists who are like, Lisp is the only, because you basically create everything you want in Lisp. It's such this wonderful programming language, and you'll get a lot of like real purists who will only ever use Lisp, even for graphics and whatever. And it's a little kind of going overboard. And so C might be a better language, from an objective standpoint, but you might not be able to code. And that's how I kind of see it. That kind of every language is, every language has its pros and cons. And even though you might think something is better, like if you don't have engineers that can use it, then.
No, but it's always interesting when you get, just for this, and then we should go on. But it's just interesting to see when people are dealing with low-level stuff where C or C++ is an appropriate language as opposed to a lot of places where it's not, but it's used anyway.
Yeah.
To get people, when people really have to dig into it and say, okay, what would you use if you were gonna start from scratch, and get people perspectives on it.
Yeah, C++ with a project this large, it gives a little bit better constraint, by having classes and some protections in there. There's only so much you can do with a plugin interface in C++. Unless you start, casting things in ways you shouldn't. But with C, there's a lot more freedom, a lot more chance for error, and I think that's probably why we went the C++ route originally. I wasn't part of that decision. I joined up later, but something like the Linux kernel is all C, and assembly, and obviously it works pretty well, and it's been managed pretty well, and it's obviously a really large-scale project. So you can do it in C with projects of this size. It's just there was enough C++ that it made more sense to go that way, and it does give you some extra protections there.
And then you can do things like client libraries in C.
Yeah.
Speed.
And then
they're much smaller, so you don't need to worry about do I need to have this so that I can subclass it or.
Yeah, so you can obviously wrap the C stuff that you want to do pretty easily. And also C++, we're using the standard template library pretty extensively, so that gives us a lot of code, like, how many hash table implementations do you want to write in your life? Like, just use the STL for stuff like that.
Well, in something as large as the original MySQL, did you encounter a lot of times where a lot of the same structures would be recreated?
Oh yeah,
again
yeah.
and again?
Yeah, if you look at the number of code paths, for example, for if you're managing a deletion of table, depending on how that was triggered, you could end up going down 5 different code paths. By starting to wrap that inside of, better class structures, you're able to avoid programmers from saying like, oh, well, I don't need it to do quite this like it was in C, I'm going to start going my own path, and you end up with like 5 different hash table implementations, and it was kind of a mess, some of the stuff that we've been ripping out of there.
If you ever want fun, take a look, go in MySQL source code and look at alter table.
Yeah. And just a side note, just make sure that alter table is not transactional safe, and even with NODB. Just a little warning there if you guys ever encounter those problems.
It's not transactional safe in all circumstances, or a subset of it?
If it's
This
modified,
discussion on the mailing list.
Yeah.
Do you mean because it will start a new basically starts a new transaction? Do you mean because it closes your
most
existing?
DDL is not wrapped inside of a transaction, especially if you're cross storage engine. You're all bets are off. But even within only NODB, the way that the table definition file, the .frm file works, you still have a race condition of when you're actually altering the table and the new FRM file is written out. There's a race condition where if the server crashed in there, you could end up with a corrupt table, even though it's probably fine underneath. So there are some edge cases there just to watch out for. One of the other big things, like I mentioned, is multi-core. Obviously we're in a concurrent world now. Don't think you're going to be, using mutexes all over the place. We've removed, I think, over 40% of the locks that were in the original server, so we're able to start using, using a little bit more memory, burning some more memory, like maybe copying things a little bit extra, but that removes some large serialization locks within the server. Like show process list is one of the most expensive things you can run inside of a MySQL server. In Drizzle, it's not the case anymore. We sort of have this dirty read operation that we do now. It'll never crash the server. You may not get the exact query that's running in your show process list output, but at least it's not going to serialize all of their operations in the server. Like I said, 64-bit using lots of RAM, and we removed all character sets except for UTF-8 because not too many people are using non-UTF-8 character sets nowadays, and the amount of conversion code that was needed to support those character sets was becoming obviously a pain to maintain within the server, and it added some overhead for operations that just shouldn't be there. Yeah.
How will this affect running it on, let's say, a single core processor with not very much memory by modern standard? Do you still expect to get the good performance?
Yeah, it should still perform really well on a single core system, but if you think about most applications, you're not going to have too many cases where you don't have at least 4 or 8 gigabytes of memory nowadays. Single core, you're going to be fine. It's just if you do want to go multi-core, you don't have all those locks in there to slow the contention down. So.
But probably single core processors are going to die. You cannot buy 32-bit CPU really.
Yeah.
All of them are 64.
Yeah.
It's a lot of old hardware around people like
Oh yeah.
this. So,
And embedded
have
applications.
you actually benchmarked it?
Maybe,
Sometimes
but
when
We
you
don't do
this
embedded
type of
anymore
thing,
with Drizzle.
It actually speeds up the more constrained.
To going to 32-bit, you mean, or to single core?
Sometimes when you clean things up, you find that all that's code that might have been used to deal with resource constraints actually, when you clean it up, it actually runs faster than the code that was set up to optimize for that. And I'm curious whether whether that happened.
Yeah, most of our benchmarks are being run on 8 or 16 core machines, and we are doing one thread at a time, so we're getting a pretty good idea of what it would look like with a single core. But we're not actually benchmarking on any single core machines or 32-bit machines because, yeah. But the idea is that we are going to have a lot of machines that are cloud servers nowadays, and they're going to be you may only want a small instance of a virtual machine, which may be single core and have 4 gigs. So we're still going to make sure it runs well, and we're not going to be slow there. But we are also thinking about 256 core machines, because pretty soon a VM you're going to be able to buy with 64 cores, just because that's what's available. So the idea though is to reducing that contention. It usually may not matter at the lower concurrency levels. It'll just you'll be at the same speed there. Did you have a question about that?
Yeah, are you going to put more detail around what focus on web applications means from a feature perspective and such?
For the feature, it was more one of the reasons, like I was mentioning before, why we started it, is to, you know, focus on the core of what made MySQL so big, in that, you know, fairly simple queries, but just making it really fast. And that's
Yeah,
that was
take something like a blog or whatever. It doesn't need
Yeah.
MySQL 5. You could run it on like MySQL 3, no
Yeah.
problem.
yeah, and not get hung up so much on the, you know, the enterprise type features. That's kind of the idea. So one of the big changes that we're doing in Drizzle is, obviously it's all open source. We forked from MySQL 6. All the contributions in or outside of Sun, they're all treated equally. If you write a patch, like Patrick has been contributing code, you know, from Lycos, and he will be from North Scale, and that code is treated upline, you know, to be merged, just like the Sun Drizzle developers too. There's no difference. We don't have any contributor license agreements. You know, anyone can contribute. The contributions are still under, you know, GPL or BSD, you know, depending on what the contributor wants to do. We use like a captain system, so we have pretty much Monty Taylor and Brian and Jay Pipes are the ones sort of reviewing most of the code at this point. So depending on, you know, what type of, what part of the system you're working on, you'll probably end up talking to one of them to get your code merged into the mainline tree.
We use Launchpad also.
Yes.
Yeah. Very, very big into Launchpad. With that, you know, it's very open development environment. You have your own tree, and you can request merges of your tree or have them review your tree. So it works out really well. Of course, MySQL is also using Launchpad now.
Yeah.
What's Launchpad?
Launchpad is the site developed by Canonical. It's sort of an open source development platform, kind of like, you know, SourceForge or GitHub or one of those sites, except it's based on Bazaar, source revision system. And they, like, Ubuntu is on Launchpad itself, and there are a number of other large projects on there too. I think GNOME is on there. It's just a distributed version control system with, you know, a nice community site put on top of it for management. The other idea is to make really make the releases often. So, you know, don't wait for like don't set out a number of features and then don't release until we hit that. You know, we're going to release every 2 weeks, whether the features are done or not, and we're guaranteed that it's going to be as stable a release as possible. We're not ever putting in anything into the mainline trunk that could potentially make the server unstable. It goes through a pretty heavy set of tests at this point to make sure we're, you know, the trunk is always stable. And the tarballs are what we drop every couple weeks. The contributors, we've had over 100 code contributions at this point, and over 500 people are on the mailing list. So in a year, we've seen quite a bit of activity. The Sun team, like, we want to make sure that this isn't a Sun-only project. You know, we want this to be a community-run project. The fact that, you know, I think we have 6 developers at Sun now that work pretty much full-time on Drizzle. You know, we've seen, I know Amazon is trying to hire developers, and Rackspace, they have open job positions. And then a number of other places, like Toru, who works at Mixi.jp in Japan. He's been one of the bigger contributors, like, outside of Sun. So we're trying to treat everyone equally, and just make sure we have, you know, a real community project here, not just a corporate-driven project. And I won't read through these team values because they're not all that important. But, well, they're really important, but you can read them.
Does it go along with Oracle? What is your feeling? So far, you didn't notice any difference.
Well, that hasn't been completed. Right now, we're Sun. We're still Sun probably until the deal goes through. We're thinking end of summer, fall. We're not sure when that's going to happen. Once that happens, it's still unknown what's going to happen with our team. But Drizzle as a project is going to live on with or without Oracle, whether they want to support the project or not. We've had enough outside contributions and enough outside interest where the developers, I mean, you know, we could go work at Rackspace or somewhere else who's already hiring Drizzle developers. So we're not too worried about what happens with Oracle. Just our team, we may, sort of fizzle out and go to other places. So, like Patrick was saying, we use Launchpad for all our project management, bugs and blueprints. Blueprints are sort of like what we're doing next with the server, like what features we're going to be adding or what re-architecting we're going to be doing. We've been translated, we switched to GNU Get Text, which has really helped our multi-language support. We're already at more than 30 languages, and that's all integrated into Launchpad as well. So anyone can go to the website and just start translating strings that were pulled out of the server. So that's been really helpful. DZR is the revision control system, and we're using other tools like BuildBot and Hudson and some other custom scripts we've developed to have automated regression suites and testing on like everything that goes to trunk. We're testing on Solaris and Linux on a number of different architectures and operating systems. So we're making sure it's pretty clean code by the time it hits trunk. So, like I said, we're really expanding on what plugin interfaces are available in the server. Rather than just storage engines and user-defined functions, you can see most of these have been added at this point. A few are sort of coming soon. Like with authentication, for example, you can just not load authentication and just have have no overhead in the system with auth. Like I was saying, MySQL still has some overhead if you disable all your permission tables. But with authentication, it's pluggable, so now you can use LDAP or PAM. You get a number of authentication mechanisms, and there's also HTTP auth, Mark Atwood added in. Storage engine interface, we still have InnoDB, and PBXT is one of our other well-supported engines, and we still have some other engines like, I think we have Archive and, Federated. Are you still maintaining that with Drizzle?
I need to get that going with Drizzle.
Okay, so we'll have Federated again. I know Monty.
We do a storage engine, right?
Yeah, not Maria.
So Maria, Monty wants to add Maria back into Drizzle. We don't know if he'll be able to do it because of how much we've changed inside of the server. Monty has more of an approach of like a monolithic code base where you're touching other parts of the system. If he wants to add it back into Drizzle, we're going to have a storage engine interface, and that's all he'll have to work within. So if he can figure out a way to plug Maria back into our storage engine interface, then we will have Maria, but we don't know if he'll put the time into doing that yet.
Is it the same plugin interface as MySQL does?
Yeah, it's very similar at this point. We're sort of cleaning it up a
So there
little
is
bit.
interchangeability between Drizzle and MySQL internal plugins.
No.
It's not binary compatible, but it's probably less than a day of code changes to make a storage engine work with either one.
Semantics.
Like PBXT, they've been able to switch over to the Drizzle interface with relatively little problem. Yeah.
What happened to Falcon? Is that still going on?
I think
Falcon is still being maintained.
It's still being
but
worked on, yeah.
I don't think its future is very bright though. It sort of never found its niche of like what it does really well to have enough support to keep it going. It's a great storage engine. It just doesn't do any one particular thing really well enough to grab a piece of the market. We haven't put any effort to porting it over, but of course, anyone's welcome to do that port if they want to. I'll talk about some of the other replication and protocol. I'll talk a bit more later. But we have a pluggable query cache, so you can have, instead of just having a big chunk of memory inside your server for your query cache, you can use something like memcached or write a plugin to put it anywhere that you would like. One of the future ones is the parser. Eventually we want to get to the point where you can have a pluggable lexical analyzer and parser, so you can extend the syntax in any way that you want at the parser level, rather than only being able to do it with the functions and stored procedure interface.
Would this allow for a complete replacement of SQL with a more reasonable query language?
That actually could be a possibility. You could still use the storage engines and the protocol stack, and just replace a new protocol, sending a different type of string into the server. And one of the things that we want to do with prepared statements is to be able to pre-compile that, possibly on the server side, or on the client side, or send it to the server and get back an abstract syntax tree of, here's the query already parsed and ready to go, so we don't have to deal with parsing it at the server level. When you want to make a query, send that blob and your attached parameters to it, and that can bypass the parser entirely. That can be shoved straight into the execution engine. So we're sticking with SQL for now because people know it, but that functionality we hope to be able to have sometime in the future. Logging and error messages, we're working on, or they're pretty much done at this point. You can log wherever you want, like syslog ability. That's something people have wanted for a long time. This way you don't have to be tailing the log and piping it into some other tool that inserts it to the log that you want. And you can just disable it entirely if you want, of course. So you can see we're looking at a lot of plugin points to be able to extend the server. More will probably be added later too.
Do you also plan to support different network protocols?
Yep. Actually, I'll talk about the protocols a little bit more in a few slides. So storage engines, most people, when we've asked them, they want NODB whether they know it or not. A lot of places have found they're on MyISAM and ended up with a corrupt table thinking that it was transactional safe, and they've been burned a few times. So we decided just make the default storage engine NODB, make it a transactional storage engine. And we want, one of the big ideas that we're pushing in the storage engine interface is to allow the storage engines to own their own metadata. This means no more FRM files that can get out of sync with what the storage engine thinks it's actually doing. Because like NODB, for example, maintains all that data, and the FRM file is just a duplication of what NODB thinks it really has. So we've removed that, allowing the storage engines to store it themselves, and we'll just query that data when we need, the DDL specific data. This way we don't have to deal with that sync issue in between. It also, we're providing a simple interface that's similar to FRM, so storage engines that don't implement their own table structures, they can store this in the supplied the supplied generic data store, and then we can read that instead of querying the storage engine of what should be done. And this is something that Stuart Smith has been working a lot on. We're hoping that patch should go into the tree in the next few weeks. He has it pretty much complete, but FRM files are gone, and the new default method on disk is going to be protobuffers, the Google protobuffers. It's sort of a serialization method that's based on classes rather than using, I think FRM files came from one of the original Unireg systems, which the file format was never documented, so trying to manually edit those files and tweak things if you have a corrupt table was pretty much impossible. Yeah?
What about the ability of database to span multiple volumes? Which is a missing feature.
I think that should be possible. I haven't worked too much on the storage engine side of things within Drizzle. I don't know if it already supports it or if they're planning on supporting it. I'd have to ask someone about that. I'm not sure. But one of the things, if you guys have any questions that I don't know the answer to, the mailing list is really helpful. Just send a message there, and someone will be probably on top of it because we all
Can people
work.
post to the message to the list if they're not on it?
You have to register for it,
Yeah.
like through Launchpad.
Yeah, I mean, worst comes to worst, if you don't want to, you can send it to me and I'll post it to the list.
And also we can put it on our board.
Yeah, we have a message board on our
Message board,
thing.
which is nice because people who are here
Right.
are used to.
Okay.
Right, so
IRC is
you're on the
pretty
list too.
helpful,
If there's
too.
anyone else here on the list, you can post to the message board. So
Messages for the
Yeah, I'll
Yeah.
post the information for the mailing list and in the IRC channel at the end, and those you can get a pretty quick answer for anything I may not know. So that's actually been a pretty significant change because the FRM files was sort of all throughout the code base. It's been sort of a pain to remove. And MyISAM, we still have it in there, but it's not a real storage engine anymore because of the way that it does locking. We're sort of redoing the entire locking subsystem, and there was just no way to make MyISAM be a full-fledged storage engine without rewriting its entire locking system. And since we don't really care about MySQL that much anymore, we're not putting the effort in. If someone wants to go back and re-implement those locking features inside the storage engine where they should be, they can do it, but we're not taking the time to do it right now.
What about the memory storage engine?
Memory is a temp table only as well. We don't have that as a, it was pretty much MySQL but a memory for the most part, and it has the same problem with locking.
So you didn't take Percona improvement, InnoDB with Percona improvement because of some licensing? Or?
No, we actually have an extra DB branch if you want to use Perconas. I don't know how well it's being kept up to date at this point, but it is available if you want to test extra DB with Drizzle. So one of the things, and this is what I've been working on the most lately, is the new protocol. We pretty much threw away the old MySQL protocol. There's still an implementation of it in the server, and that's still the default at this point, but we're in the process of removing that and implementing it with a new library that I've written. The idea is to have the protocol fully, have a full duplex and asynchronous, so when you send a query on a single connection, you don't have to wait to get a response back to send your next query. You can just start shoving queries down the pipe, and they can come back in any order. You know, the result sets can come back in any order. So this means re-architecting the way the entire protocol works. There were a lot of limitations within the protocol where they were using fixed size lengths, and then if you're, actually have to go over, you have to set a certain bit and start expanding. We've made the protocol a lot more dynamic so we can add new features without, having to have all this complex versioning. And like I said, this allows concurrent queries on a single connection. We've removed multi-statement on a single command, so you can't have select something, semicolon, select something, semicolon in one command. You actually send two separate protocol packets to do that. This way you don't have really weak attack methods, like, having an unquoted string and putting a drop table in there.
Are you talking about concurrent selects, not concurrent updates? Then how are you doing it?
So, yeah, this is a question I get asked a lot of, what does this mean when you're within a transactional context, and how guaranteeing the order. So when you're sending queries, you're going to be able to have things wrapped within a single transaction or concurrent transactions at the same time. So if you don't care the order of transactions, just send the queries down. But if you want to make sure things happen, serialized, make sure you're sending the queries in the right order. So it's sort of up to the client to do what it wants. So you can send multiple updates or multiple inserts, but you have to make sure they're not going to overwrite each other and cause problems in your application if they were executed out of order. Does that answer your question?
I guess then it is up to the application developers to
Yeah.
decide
Yeah, but say your common web app, say like a WordPress blog, they're just displaying the front page of it. You may have 5 or 10 select queries. You don't care if those are all run in a single transaction. You can just blast all those queries at the same time, and you may have just cut your query load or your query time for your page by 10 if they were all taking the same time. So this concurrency is going to allow you to scale much better with a single connection, which means less load on the server.
You're not really doing any kind of detect whether auto commit is turned on or not at that point. I'm just wondering what.
No, we still have auto commit.
Okay.
So you can still do that, but it's still left up to the application developer to do the right thing. And inside the server, we actually haven't done the code that will run multiple queries in parallel. At the very least, you can shove all your queries down at this point and get the result sets back, and they will be executed serially. But very soon, we're going to change the execution engine so it can start popping queries off a single connection to be running them concurrently. And if you don't want them run at the same time, or if there is some dependency there, just don't send it yet on the client.
When you have them running concurrently, would that be dependent upon multiple processors? I'm not sure that there's any advantage to trying to run on a single processor.
Yeah, the main advantage, well, there could be, because there are other blocking factors besides CPU. If you're a disk-bound load, you may want to have 2 scans going at the same time. If you can see that there's some overhead there, but we're sort of thinking, okay, you have 64 cores and you need to run 16 queries. It makes sense to be able to run those concurrently if you don't care about the order in which they're run. So you can either open up 16 connections now and run them all at once, but that's going to be a lot of connection overhead that you could avoid by just piping that through a single connection.
And then basically, when the query connection is not blocking, you got to call back with it.
Yep. Yep. Yeah, the new library interface, the callbacks are not in there yet. Right now, you sort of just batch up all your queries, send them, and there's a function that will return when one result set has started being flushed back, and then you can read that. And it's fully non-blocking too. That's one of the things I did in the new libraries. You actually have a non-blocking interface. You don't have to block on every query. So if you have other file descriptors that you could be listening on, you can go do work on that. You don't have to sit inside of a database call. One of the other big things with the protocol is it's pluggable, so we can support things besides the default Drizzle protocol, and we actually support the MySQL protocol as well. One of the other things that we did were built-in sharding and optional checksums. Say if you want to have sharding, but you don't want to do it at a proxy layer, and everyone is writing their own sharding algorithm inside their code. We're actually putting some simple sharding algorithms, basically some hash algorithms, inside of the library itself, so you can just use that to shard your queries depending on some user-supplied key. It's just sort of like a nice thing we're adding in. And at the same time, we're having an optional sharding key inside of the protocol. So you can put that key into the low-level protocol packet. So if you were running a proxy in between, it could be looking at some external key rather than looking at the query to determine where to send that query to. There's some people that are already looking at making hardware routers for database load specifically. So if they had something like a sharding key that they could look at in the low-level packet rather than having to parse some query to see which table they were hitting and sharding on that table name, this sort of gives them a much easier way to do it. And even the software proxies that are doing the sharding, it makes it a lot easier for them. It's a lot less processing. And we're also going to have optional checksums. You can set a bit to turn on. I think right now we just have CRZ32 checksums. So the protocol stack, like someone asked earlier about what other protocols we'll be able to support, I abstracted the protocol into a plugin class. So you can go in and extend that base plugin class and write, say, a HTTP interface on top of it to give a REST interface. So the new protocol is embedded inside of libdrizzle, and that speaks both Drizzle and MySQL protocols. Other protocols we're looking at adding are things like memcached. You're thinking like, why would you want to talk memcached to a database? But just think of it as a cache that can be populated by a SQL query and have a query cache in there in between. This removes a layer in some architectures. If you can query the database directly with a memcached request, and if it doesn't exist, you could actually run the query on the back end, populate it, store that in the pluggable query cache, which may actually be a real memcached server on the back end. It simplifies your application by quite a bit. And we're going to eventually add a Gearman client interface as well. Yeah.
What about supporting non-TCP/IP transports?
It's possible. It's a plugin class, so you can sort of extend it any way that you want. One of the things I'd like to do at some point is to write it so you could basically be executing from a thread pool. So you could, in fact, run Drizzle as an embedded application and you make your queries from external threads. So you're not tied necessarily to be running on a socket of any kind. You can extend it, and you just have to implement functions that are able to read a request and send back the response at the field and row level. And if you can do that you can map that to any protocol you want at the other end. So libdrizzle is what the new protocol has been implemented in. It's a separate project, mainly because it's all new code. I didn't reuse any existing code from MySQL. It's BSD licensed, so you can use it anywhere. There are no restrictions on what you can do with it. Like I said, it supports both Drizzle and MySQL protocols. It's not only a client library, it's actually both client and server. There's an example in the libdrizzle source where I use the server interface on top of SQLite, so you can actually connect to SQLite with a MySQL client over a TCP socket. I'm not sure why that's really that useful, but it's showing that you can use this to put a MySQL or Drizzle interface on really anything that can look like a database. I know there's been some people wanting to put this on other databases, even possibly putting this into something like Postgres. So you could use a proxy that could route to either a MySQL, Drizzle, or Postgres from a single application without knowing what they're using. They're just using a single client protocol. We've had a number of other language extensions written. I did the initial PHP one, although that's being maintained by another PHP developer at this point. Patrick, you can talk about that.
Yeah, I've got DVD Perl support, and that's coming along nicely. It works pretty much just like DVD MySQL. There's also a wrapper around Drizzle and Perl done by a fellow, I'm trying to remember his name, he's in Japan. He just recently released that, so DBI doesn't give you the ability to do the multiple queries and parallel queries, but this wrapper would allow you to do that.
What about JDC and connected area?
Yeah, we actually, there's one guy, I think he's in Sweden. He wrote a pure Java implementation of the protocol in Java, so that's available as well. We've actually been using it in testing for a few other applications, so it works reasonably well at this point.
And would that be extended for the I'm just trying to think of how the multiple query results set returning is going to work with.
Yeah, to be honest, I haven't looked at his implementation, so I don't know how he's handling the concurrent query support yet. But again, that's probably something you could. I know he's on the mailing list and hangs out in IRC often, so you could ask there.
Are you wondering how you would handle the result sets and how you would map the result sets to what query you ran and the order? Yeah, I was
usually it's just going to be serially get connection, pull back into the result set, and you handle it, and connect. But I mean, certainly if you do that, but how would you take advantage of this?
In the C library, I did it by just every time you submit a query, you get a result object back immediately with a ID embedded inside that object that associates every packet coming back will be populated inside of that object.
Right, so you can just create a thread for each one and then pull them back when they come back in.
Yeah. Yeah, or even in a single thread, you may just have a list of result sets of all the queries you've submitted that are not complete yet. And they'll just be populated. When one's done, you can have something notify you saying, go look at this result set. And in the library itself, all the various languages, I think most of them, except I guess the DBI driver, because you're working with
DBI is always serial. You prepare a statement. Of course, the driver emulates that, and you execute the statement, and it gives you back a result set, and you have to do that serially. And there's no way to take advantage of these features that he's added. But like I said, there is that not pure Perl, the wrapper around Drizzle that was just recently released.
It's a Perl XS. XS is the extension language in Perl.
Thinking of even utilizing that with DBI instead of what I have. I don't know. You might know.
Is DBI being actively maintained now?
Pardon?
Is the Perl DBI live interface being actively maintained?
Oh yeah, definitely.
Any development going on that? I haven't seen anything.
Pardon?
Yeah, I'm just wondering. I haven't seen if there's still
on DBI itself or the MySQL driver part of it?
No, I'm thinking of the DBI itself. Being extended. It's presumably would be something that it's not going to multiple queries and parallels. Presumably not going to stay unique to MySQL if it is now.
I don't know what their plans are with regard to that. DBI, there's so many databases utilizing DBI, so it's not something that you can easily just throw in things. It's easy when you have something like Drizzle and say, I'm going to add this for the Drizzle driver, but DBI is used by so many other databases, so it's a bit of a standard, and so there are more people it has to go through, and I think Tim Bunce is still maintaining that. But as far as adding something like that, I'm not sure. That's a good question.
So the next plugin that we've sort of ripped out entirely and re-implemented is replication. If you know any MySQL replication, it was completely ripped out of the server. We've replaced it with a plugin interface. And right now we don't have any default implementation, although we have a simple logging to disk example, which can be replayed in the server. And eventually, one of the bigger goals that I want to do is write a Gearman plugin, so you can pipe all your replication events out to a Gearman network, and you can sort of just attach feeders of that, so your bin log can be maintained externally. It doesn't have to be maintained on the same disk or on the same machine, and you can offload some of this replication load. And it's going to be easy enough to plug in, so you can start pulling these events in any language that you want. You know, if you actually want to read the bin log and get access to these raw events, we have some clients that want to have the MySQL replication stream populating memcached, and they really have to do some hacking to be able to support that. Now it'll be really easy with a well-defined interface to say, pull the stream out and shove it over here, and you know, you don't have to worry about all the funny stuff that can happen with a MySQL replication system. Do you have a question?
So you said you forked 6.0, so this is not statement level replication, it's
Everything is basically row-based replication.
row-based replication.
Yeah. I think we're still doing DDL in statements. And there's a few other special queries that are being pushed around in statements, but we're trying to move entirely to row-based replication. But once we have that you know, that core implementation, we want to start expanding row-based replication, so we don't have things like when you update a 1,000,000 row table, you don't actually send 1,000,000 events. You can.
Doesn't that switch to statement level based on the load right now?
What's that?
I'm not that familiar with that.
Okay.
I'm more familiar with.
You're
the
thinking
regular,
about
Yeah.
mixed mode, right?
doesn't
Yeah.
if you have an update for like 100,000 lines, isn't it going to just switch to statement level? Isn't that
Yeah.
what it does? Statement
That's mixed mode. You can still force row-based, and it will actually send 1,000 or 1,000,000 or however many rows, that many events. So yeah, we're trying to work towards row-based, but having an efficient row-based rather than, you know, just sort of a brute force row-based replication scheme. So yeah, we're trying to make it really easily extendable to plug into your, you know, infrastructure, so you don't just start. You know, if you look at the number of hacks that have been of converting a MySQL bin log and all the various versions that there've been of that bin log, piping into something useful, it's starting to get a little bit ugly. Like I mentioned in the other screen, there's quite a few other interfaces we're adding in. I think I talked about most of those already. One of the big ones that we're working on now, Monty Taylor is working on, is multi-language support. So you'll be able to write things like, when we add stored procedures back in, you'll be able to write them in something like Perl, or if you want to write a replication module, you can write that in Python. You don't have to learn C in order to start pulling things out. Maybe this isn't something you want to do in production, but at least for prototyping, it's gonna really help your development.
If you want to do that in Java, how you work with JVM?
We haven't tackled that one yet. Yeah, there's a few Java people that have talked about either, you know, just having an external JVM and, you know, opening some type of inter-process communication there, but we're mostly looking at embedded scripting languages at this point.
You can ask Oracle because they have embedded Java.
Well, MySQL does with the Eric Herman and Anthony Curtis. He did Java external language stored procedures. Anthony did the Perl ones, and
But
I don't know what Eric used.
Yeah, but those externals, they kind of almost dead now. No.
Yeah, there's not a lot of love given to it.
Yeah. We'd probably be looking at how Postgres has done some of this stuff. You know, they had the advantage that they're a forking database server, but there's still some good ideas we can pull from their language interface, because they've done it right for the most part. And, you know, being open source, we can look to them for some ideas.
Can I ask a question?
Yeah.
The graph a long time ago had this box called Scheduler.
Oh yeah.
Is that all
Yeah, oh yeah, the scheduler plugin. I probably shouldn't have skipped that one. So right now, the scheduler in, you know, default MySQL is 1 thread per connection, and it's the same way in Drizzle right now. But we're looking at different schedulers like pool of threads. So you can have, you know, say you have a fixed size pool of 32 threads, but when you have, say, 1,000 connections, they're all being multiplexed onto that smaller pool of threads. So that way you don't have, you know, if you have 1,000 connections or even 10,000 connections, which is pretty common in really large web shops like Google, you don't have 10,000 threads running, you know, because that contention and overhead is going to pretty much kill your process at that point. So being able to do other types of schedulers of mapping queries onto the runnable thread, that's pretty much what the scheduler does. So in some way we're sort of rewriting some of what the operating system does, but we need to because we're dealing with, in some cases, such large sets of file descriptors.
Do you do anything like single query gets executed by multiple threads? Kind of.
No, we're not. That's sort of a completely different part of the code. That's within the execution engine, and for the most part, that's been left alone, minus ripping some of the features out. At some point, we may look at doing that, but that's pretty far out on the radar. You're saying like if you're joining two tables and doing two concurrent query scans or index scans in separate threads.
You can imagine that you do a single table scan by dividing the table into parts and running like a parallel and joining together results.
Yeah, it's not quite that advanced.
But isn't it the function of the storage engine?
Well, you can still do that. Say if you're joining two independent tables within one storage engine, and you're not pushing that join condition down into the storage engine, you could create two separate threads, you know, that would look like two connections into the storage engine or two queries into the storage engine, and then join those results in the kernel level and give some results that back. So there are some things we can do that would be smarter in the kernel, but yeah, another way to do it is to push those conditions down into a storage engine. You just would need a storage engine smart enough to handle them. This slide shows the code base, you know, how many lines of code we're at. So we've worked for MySQL 6, which was over 1 million lines of code. Revision 950, that was, I think that was back in April. You can see a little over 312, and at this point we just dipped under 300,000 lines of code. So you can see we've ripped out a lot of it was just dead code that was not even being used anymore, which was just sort of confusing of why does this file exist? Oh, it's not being used anywhere. Let's just remove it. And in some cases we're just doing a lot of cleanup where there are redundant code paths of, you know, like I was mentioning, deleting a table instead of having 9 ways to delete a table. Let's just make it one way, which obviously reduces the code load. So we've been changing a lot of the internals. Our milestones, they're named after streets in Seattle, since Drizzle was named after sort of the weather in Seattle. Well, I guess we can name it after the weather in Boston then. So our next milestone is in August, and we're hoping to have most of this stuff done. Most things I've already talked about, like table discovery was the removal of the FRM files and allowing the storage engine to own that. There's still a lot of re-architecting in the core kernel code we've been working through though. The next milestone, we're not trying to think too far ahead. We're sort of waiting until we get to, you know, a completed milestone, and we're trying to do this every 3 months and just reanalyzing. And don't set milestones out 2 years in advance, because then you sort of make a commitment of like, oh, I need to do this, so we're going to do this regardless whether it makes sense or not. You know, we're reevaluating everything at each milestone step and seeing what's the most important thing to have done, because you're going to receive different feedback from the community of, you know, what should be done next. Either to help more developers get involved, or to, you know, at some point, people are running this in production, what do they really need? So we don't have too much for the milestone. That'll be completed at the end of the year. Server-side scripting, like the multi-language support, is one of the big ones. And the performance schema work, you know, be able to query some better statistics out of the server. And anything that you guys can think of, put it on the mailing list, or you can start hacking on the code base yourself. So these are all the links of ways to get in touch. The main Launchpad project is there, the IRC server. I'll send out these slides too, so if you don't have to write everything down. And the main drizzle.org site has links to pretty much all this as well. At OSCON on July 20th in San Jose, we're going to have a panel with all the core, or a number of core Drizzle developers, and Patrick and Ronald Bradford will be up there representing some of the community members. We're going to have a birds of a feather, and we'll be in the expo.
That's on the 23rd, right?
Yeah, it's the week of the 20th. Yeah, you get there the 21st. Yeah, OSCON is the whole week of July 20th. The actual Drizzle stuff will be happening on Wednesday or Thursday. I think Thursday.
Thursday, yeah, I made sure my ticket was,
Hopefully you'll be there.
oh, well.
Is there anything else with Drizzle as far as questions before we switch to Gearman? Sure.
You mentioned no information schema materialization, meaning that it's always on disk.
No, meaning that when you need to build it, if you want to query one specific set of information out of that, like say if you're just querying something from the columns table, you don't need to, right now in MySQL you have to materialize the entire information schema database before you can pick out that one value from the one column table. We're trying to make information schema a lot more efficient so it's not such a load on the server, because building that materialization every time you query it can be pretty expensive as far as the concurrency issues are concerned. So we're looking at, we actually have a Google Summer of Code student, and Stuart Smith, I think, are mostly working on that right now. So.
Stuart Smith was of NDB cluster fame.
Yeah, he was there for 3 years working on MySQL cluster, the NDB storage engine. So he's one of the ones we were able to steal from the MySQL folks.